The concept of zero is one of humanity's most profound intellectual achievements, a simple yet revolutionary idea that transformed mathematics, science, and technology. Its journey begins in ancient civilizations, where the need for a placeholder emerged as societies developed increasingly complex numerical systems. The Babylonians, as early as 300 BCE, used a symbol to indicate the absence of a value within their base 60 system. However, this was not yet zero as a number, merely a way to ensure clarity in representing larger numbers. The Mayans independently conceived a placeholder for zero in their base 20 system around the 4th century CE, a remarkable feat that demonstrates humanity's universal problem-solving instincts. Yet, neither the Babylonians nor the Mayans treated zero as a number in its own right. It was in India, during the 5th century CE, that zero underwent its transformation from a placeholder to a full-fledged numeral, carrying its own identity and rules. Indian mathematicians like Aryabhata hinted at the idea, but it was Brahmagupta who, in the 7th century, formalized zero's mathematical properties. He defined it as the result of subtracting a number from itself and recognized its utility in equations, paving the way for arithmetic operations that would have been inconceivable without it. Zero's significance extended beyond India through the work of Islamic scholars like Al-Khwarizmi, whose treatises introduced Indian numerals, including zero, to the Islamic world. His works were later translated into Latin, bringing zero to Europe, where it met resistance. Europeans, accustomed to Roman numerals and wary of concepts with no physical representation, were slow to embrace it. Zero was considered almost mystical, even dangerous, as it challenged established norms of thought. Despite initial resistance, the adoption of zero was inevitable due to its unparalleled utility. Its presence enabled the development of positional notation, where the value of a digit depends on its position within a number. This innovation was critical for performing arithmetic efficiently and laid the groundwork for algebra, calculus, and eventually modern computing. Without zero, there would be no binary code, the language of computers, and thus no modern digital world. Zero also holds philosophical and existential significance, representing both nothingness and the potential for infinite possibilities. It is a paradoxical symbol that embodies the absence of quantity while being essential to the structure of our numerical and logical systems. In mathematics, zero serves as the origin point on a number line, the fulcrum of balance between positive and negative values. In calculus, it enables the concept of limits and derivatives, revolutionizing our understanding of motion and change. The life of zero demonstrates the profound impact a single concept can have on the trajectory of human knowledge. From its humble beginnings as a mere placeholder to its role as the foundation of modern mathematics and technology, zero illustrates how abstract ideas can transform practical reality. It bridges the gap between the tangible and the infinite, empowering humanity to explore realms of thought and existence previously unimaginable. In many ways, zero is not just a number. It is a testament to human ingenuity and the boundless potential of intellectual exploration.